This class will solve these three questions. Exercise 6.2, class 10. Okay, triangles. Okay, so here question number B4, we'll find this on textbook page 134. So there is a figure given to us, so let us draw that figure first. As you can see there on your notebook, something like this is given to us, so let us draw that. And here A, B, C, and here this line here, DF is parallel to AC, right? DF parallel to DE parallel to AC. Then here, from here, there is another. So this line is joined here, meaning AE is joined. And here there is another line here that is parallel to, which is here DF is parallel to this AE. So that is given. So let's do that. Given to us here clearly in the figure that is here, DE is parallel to AC and DF is parallel to AE. This much is given. We have to prove that. With this, we have to prove that BF by FE, BF by FE is equal to BE by EC, BE by EC. So this is what we have to prove. Now here, proof means our answer for that. Here, let us see here this this portion of the triangle ABE. Let us take in triangle ABE. Okay, so here in this triangle we have that given us is DF parallel to AE, because it is given in the question to us, right? Here, see DF parallel to AE. So we know that in this triangle ABE, if a line is parallel to two sides, parallel to one side of the triangle AE, it will divide the other two sides AB and BE into same ratio, basic proportionality theorem. So here, this one here, BF, by looking at this we are doing also, by FE, this portion by this portion, which is this, is equal to here. This line cuts this side also, this one. BF means, on the numerator, means BD here, corresponding BD by here DA or AD. You can write AD or DA, and write your since using basic proportionality theorem. So that is the reason for writing this ratio form, right? So here let us treat this one as equation number maybe 1. Then let us take the other triangle. Here we have taken ABE, this one, these triangles. Let us take the big one, ABC. In this triangle ABC, we know that this line here DE is parallel to, as you can see here, this side AC. So in this triangle ABC, this line DE parallel to AC means this DE will cut these two sides which it touches in equal ratio. So there will be BE, you can write here BE, therefore BE by here EC, because this line is cutting this side here into BE EC, means equal to, now corresponding ratio is BE, means this line cut here, means we have to write BD by DA, BD by DA. So this reason is because of the same theorem basic proportionality theorem. So we can just write there do. Now look at this and you'll see here BF by FE. BD by DA. Here same. So we can write here BE by EC without touching. And BD by DA, which is the same as this in equation 1, can be replaced by this one, BF by FE. BF by FE. Reason is, since using equation number 1, okay? So hence proof, the answer. See here, BF by FE equal to BE by EC. To prove, BF by FE, which one is this one, is equal to BE by EC, proved, right? This is the first question. The next question is 5, question number 5, B5. See there, in the figure 6.24, page 134, DE parallel to OQ and DF parallel to OR. So let's draw that 6.24, which is something like this. You can clearly see P, Q and R. Then here, this line is here EF, here up to here, let us say this line joined and this line joined. So here O, and then here let us say this line here parallel, this one, these two are parallel, and these two here are parallel. Question is saying that, so D. So here given in the question is, in the figure, means this figure given to us here, DE is parallel to OQ and DF parallel to OR. These two are given to us. We have to show, means to prove only, to prove that EF is also parallel to QR. EF parallel to QR. This one here, EF line parallel to QR. We have to prove. So for that, let us just start a proof, means our answer. Proof here, let us take this portion of the triangle here, POQ. So we write here in triangle POQ, which is this one. The tracing of my pen here. This line here, ED or DE, is parallel to OQ. So in this triangle, DE parallel to OQ. So this will cut these two sides, PO and PQ, in equal ratio. So PE by EQ. PE by, here we can write given, therefore PE by EQ will be, this is the parallel line touching here, so PD by DO. PD by DO, since using basic proportionality theorem. Let's give this one as equation number 1 and proceed. Take the next triangle like we did just now in triangle. We have to POQ. Now let us take POR, this portion. POR. In that one, DF here parallel to OR, as you can see here. DF parallel to OR, as it is given to us in the question. So now, applying the same basic proportionality theorem, this one here, PD by DO, will therefore be equal to PF by FR. Because this line DF is parallel to this one, means it cuts, DF will cut PO as PD by DO, and will cut the other one, PF by FR. And we know The reason is same as the previous one, basic proportionality theorem. So we can just rather do. So here now we can see PD by DO is common in both here. See, this one can be replaced by here PE by EQ. PE by EQ, and here PF by FR. You can write your since using equation 1, putting it here. So now let's put this one as equation number 2. So here in triangle PQR, the big one, PQR, now we can see this one PE by EQ equal to PF by FR, as we know by using equation number 2. In other words, PE by EQ equal to PF by FR means PE by EQ equal to PF by FR means this line EF divides this side PQ, and the other side here PR in the same ratio, means equal ratio, because this is ratio equal to this. So this theorem, there is one theorem which says that if a line like EF divides two sides of a triangle in equal ratio like this, that line is parallel to the third side QR. So we'll write here, therefore EF is parallel to QR, and the reason for this is since using converse of basic, this is the converse of basic proportionality theorem, converse of basic proportionality theorem. So EF parallel to QR is now proved, right? So that's how we do it. Okay, now next, one more question, the final question. It's B6, page 134 of your textbook. 6.24 figure. A, B, C are points on OP, OQ, like that. Let's just draw the figure first. So there's a figure like this, and then there's a line here joining the middle point like this, and there's a point here like this, and like this is there. That this is P, Q, and R. This is A, B, and C. This is O. That much is given. So 6.25. So in this triangle, given means in the question, in the figure that is given to us on the question, A, B, and C, A, B, and C are points on OP, OQ, and OR respectively, such that AB parallel to PQ. AB is given as parallel to PQ. AB is parallel to PQ, and SC is parallel to PR. This much is given. You have to show, means to prove, that BC is also parallel to QR. That's what we need to prove. So in this triangle, let us take POQ first. Prove this answer for this. In triangle POQ, AB is given as parallel to PQ. It is given, as you can see here, AB parallel to PQ. So if a line is parallel to one side of the triangle POQ, it will divide those two sides where it touches in the equal ratio, means OA by AP, OA by AP will be equal to OB by BQ. OB by BQ, and reason is since using basic proportionality theorem. So that's our first derivation we're getting, subderivation. We can do the similar thing with the next triangle, in which the other line is parallel. SC parallel to PR means we have to take this triangle POR. So in triangle POR, SC is parallel to PR as it is given in the question, as you can see here, SC parallel to PR. So we'll divide this side and this side in equal ratio, means OA by AP is the same as this. OA by AP will therefore be equal to OC by CR. OC by CR. OA by AP, since using same theorem, so you can just write the do. Okay, then here you can see these two are same, can be replaced. This can be replaced by this value now. OB by BQ replaces this, because this one is equal to this, as you can see here, will be equal to OC by CR, and you can use here since using equation number 1, as you can see here. So now you can put this one as equation number 2, and in triangle PQR now, finally the big one. Okay, and this one, no, we have to prove BC equal to, or QR, not the big one, sorry, this one, BC parallel to QR means this triangle QR. Now in this one, we see here this one, OB by BQ is proven to be equal to OC by CR. So OB by BQ equal to OC by CR. We get this one by using equation number 2. So in other words, this means this line BC divides this side here OQ, and the other side BC touches this one also, OR, in the same ratio, means in equal ratio inside this triangle QR. So we know that if a line divides any two sides of a triangle in equal ratio like this, that line will become, BC will become parallel to the third side here, QR, and we know the theorem is called using converse of basic proportionality, theorem. Okay, so that is your answer. So this concludes the part. You can go and give the test for this one. Okay.